વિદ્યાર્થી મિત્રો, લક્ષ સ્કૂલ ઓફ સાયન્સ બામણમાં ઓનમાં ફરી એકવાર આપણું સ્વાગત છે. આજે આપણે થોડીક સ્કૂલની યાદ કરીશું. ઘણા દિવસ થઈ ગયા સ્કૂલ જોઈને. આપણો ઓનલાઈન અભ્યાસ ચાલી રહ્યો છે. થોડીક સ્કૂલની માટીની સુગંધને અહીં આપણે જોઈશું તો મજા આવી જાય. તો ચાલો સ્કૂલની ઝલક જોઈએ. આપણું સ્કૂલનું આ સિમ્બોલ, આપણી આ સ્કૂલનું બાહ્ય દેખાવ કેટલો સુંદર છે. જો ભારત માતા સાથે આ આપણું એન્ટરન્સ. અહીંથી તમે અંદર સ્કૂલમાં વારંવાર જાઓ છો અને યાદ આવતી હશે બધી. કેટલું સુંદર અહીં લાગી રહ્યું છે. આ આપણે હોલમાં બેસીને પ્રાર્થના કરીએ છીએ, ભેગા થયા છે, મિટિંગો યાદ આવે છે કશું? હાલના શબ્દો નિલેશભાઈ ને આપણા વાતો બધી તો બધું મિસ કરી રહ્યા છે. તો થોડુંક આજે આપણે એને દિલથી યાદ કરી લઈએ એવી ઈચ્છા થઈ. જાત જાતની એક્ટિવિટીઓ આપણે કરીએ છીએ. આ બધું ખૂબ જ યાદ આવતું હશે. પ્રવાસો હવે તો આ વર્ષે ભૂલી જવાનું છે. આ બધું રમતો સ્કૂલને આ રીતે આપણે યાદ કરીએ અને પછી ભણીએ તો મજા આવશે. Welcome back, dear students, to the Lux School of Science. And today in chemistry, we are going to talk about the lesson number 9, coordination compound. In coordination compound, we have talked already lots of things, and today we are reaching on to the isomerism. Dear students, you know the definition of isomerism. In isomerism, we used to say that same number of same kind of the molecular formula, but the structural formula is different, and that kind of isomerism is developed. Such isomerism is known as structural isomerism. But sometimes the molecular formula are same, structure formula are same, but the arrangement of bond are different. That is also isomerism. Sometimes we will find the same molecular formula, same amount, same structure, same bonding, but the direction of bond is different. Okay, in space the arrangement is different. Same structure, but the left arrangement, right arrangement, such arrangements are there. And this kind of isomerisms are there. So in complex compound, we are also having lots of such kind of figure because of the number of ligand. Okay, so number of ligands can be arranged in space in different pattern, and it will give us the isomerism. So dear students, come on, let's study isomerism in coordination compound. Isomerism in coordination compound. So now, after brief introduction of the coordination isomerisms, I would like to give you the isomerism in coordination compound is divided actually into the two part. So first part is known as geometrical isomerism and space isomerism, and both combine to give you the space isomerism. The space isomerism is also known as stereoisomerism. That since starting I am speaking about stereochemistry. So stereochemistry is actually stereoisomerism. So first kind of isomerism is stereoisomerism. Okay, and the second kind of isomerism is structural isomerism, that I have explained. So there are two kinds of isomerism we are going to study in coordination compounds. So in coordination compounds, the first one is stereoisomerism. Dear students, stereoisomerism is furtherly divided into two categories. The stereoisomerism is also divided into the two categories. One is geometrical isomerism. So geometrical isomerism is nothing but when we will arrange the ligand in the space, then the arrangement of the ligand in the space occur in different direction, and that different direction may lead us the different kind of structure, and such different kind of structure is here known as the geometrical isomerism. So this is talk of a geometrical isomerism. Same thing we will go with the another kind of the isomerism, and that another kind of isomerism is actually optical isomerism. Okay, so optical isomerism is also in space the arrangement is different, and due to the reflections of light may be different, and that will give us idea of the optical isomerism. So dear students, we have two kinds of isomerism. First one is stereoisomerism, second one is structural isomerism. Actually, stereoisomerism is divided into two categories, that is geometrical isomerism and optical isomerism. So dear students, now we are going to talk about the structural isomerism. Actually, structural isomerism is divided into four parts. So that also you have to remember that the structural isomerism actually divided into four parts. So first part of the structural isomerism is linkage isomerism. So due to the link of the coordination bond, whatever the isomerism is obtained is known as linkage isomerism. Okay, second one is coordination isomerism. The coordination bond is developed, and in what way the coordination bond is going to make different molecules, that is nothing but the coordination isomerism. Next one is ionization isomerism. The ligand develop the ionization, and ionization means the Cl should inside or outside the coordination sphere. That kind of isomerism will be developed, and that is known as ionization isomerism. And last one is solvate isomerism. So these are the four parts of the isomerism of the structure. So due to the structure of the coordination compound, whatever the isomerism is developed, such isomerism is known as structural isomerism. And due to the structure, linkage structure, due to the coordination sphere, due to the ionization part, and due to the solvation part, whatever the isomerism is developed, and such thing we are going to talk about here. So I hope that you understand there are total 6 categories of the isomerism: geometrical isomerism, optical isomerism, then linkage, coordination, ionization, and solvate isomerism. Okay, actually 2 types of isomerism: stereoisomerism and structural isomerism. So this is our story about the isomerism in coordination compound. So come on, let's study one by one all the isomerism. So dear students, first we are giving heading to study geometrical isomerism. So our heading number 1, in stereoisomerism we are going to talk about geometrical isomerism. Okay, so geometrical isomerism can be defined in this manner: when ligands arranged in the space and isomerism is developed due to the geometry of ligand, then such kind of isomerism is known as geometrical isomerism. So dear students, in geometrical isomerism, we are going to talk about that when ligands arrange in the space and isomerism is developed due to the geometry. Okay, such kind of isomerism depends on the coordination number. Dear students, now you know the coordination number. So definition of the coordination number is very simple. What is the definition of coordination number? The number of coordinate covalent bond attached with the metal ion or the central atom, that is known as the coordination number. And coordination number we have studied about 2, 4, 5 and 6. Dear students, in our book and generally we have idea that 2 coordination number cannot be developed the isomerism, but 4 and 6 numbers are developing the isomerism. So here what we are going to talk about isomerism will depend on to the coordination number 4 and 6. So now here first part we are going to study is when coordination number is 4. So when coordination number is 4, at that time which kind of isomerism is developed, that we are going to talk. See dear students, here I am getting example Ma2B2. Ma2B2. A2 times B2 times total 4 ligands are attached to metal ion, and such is our first topic to understand. So dear students, when 4 coordination is there, we have to cover it into 2 into 2. 2 ligand of one kind, 2 ligand of another kind, and then only the first kind of isomerism is developed. So remember, when we are talking about 4 coordination number, at that time 2 into 2, that is the 4 coordination number, and 2 one kind and 2 another kind ligands will be developed. That's we have written Ma2B2. Okay, so now here we are going to talk about this isomerism. So in isomerism, in space, the arrangement of 4 ligand will be shown in this pattern. Always 4 ligand ને તમારે આ રીતે બતાવવાના છે. But 2 ligands are AA type attached at one side and BB type are attached is one side. So this is our first structure. In second structure, we can draw same thing we can draw, but here the AA kinds are in opposite portion and BB kinds are in opposite portion. So AA and BB kind of structure are there. So same side, opposite side. In the Latin language, same sign is known as cis. So this is our cis kind of isomerism. So first, geometrical isomerism, in coordination number 4, we have developed cis and here trans. So there are 2 types of isomerism. Cis means same side, trans means opposite side. So this is our first category to understand the cis and trans isomerism in the coordination geometry. Dear students, here we can take example of nickel is attached with Cl2 and CO twice. So this is our first part to understand about nickel. Here in nickel 2 chlorines are there and 2 carbonyls are there, and they can arrange themselves. Nickel at center, okay, 2 carbonyl here and 2 Cl here. So this is one same side case, and this is cis trans isomerism. Same thing you can do, CO taken here, CO taken here and Cl taken here. So these are now opposite, and as they are opposite, it is a trans isomerism. So dear students, no matter to worry about this, because this is very simple, and first thing is completed here. When coordination number is 4, such kind of isomerism is developed. Now second portion of the geometrical isomerism that we are going to talk about, and that is the number 2, when coordination number is 6. So when coordination number is 6, at that time, according to that geometry, the number is divided into two parts. First one is 4, 2, and second one is 3, 3. The total number 6 can be divided into two categories. First one is 4, 2, and second one is 2, 2. And according to that, now we are going to talk about the isomerism. So first we are taking when 4 and 2 number of ligand. That means now the story is Ma4 and B2. Now a story is Ma4 and B2. Okay, and now this can be arranged in this manner. M is in center. Now all 6 coordination, you have to arrange them in this pattern only. So 6 coordination આવી જાય તો તમારે આ રીતે જ arrange કરવાનું. બે આજુબાજુમાં ઉપર નીચે એક. So everywhere you should attach in this pattern, and that will give you very simple. 6 આવ્યો એટલે આ, 4 આવ્યો એટલે પેલું. આ ઉપર મૂકી દીધા એ 6 થઈ જાય. ને ઉપરથી કાઢી નાખ્યા તો એ 4 થઈ જાય. So આ arrangement છે. Now this arrangement 4, and so A, ચારે ચાર A એક બાજુ છે. All 4s are one side and B are at the another side. So this kind of arrangement is there. And here in this case, we are taking this 2A one side, but 1A is taken here. Now यहाँ B यहाँ મૂકી દઈએ. So this is our arrangement. કે A ના સામે A આવી ગયો, B ના સામે B આવી ગયો. So this arrangement is again same side. So it is known as cis arrangement, and this is again opposite side. So this is known as trans arrangement. So coordination number 6 is also having cis and trans isomerism, and in this cis and trans isomerism you will find for all A one side, B one side. Here you will find AA are opposite side, BB are opposite side, and that is the trans isomerism. So hope that you understand this 4-2 manner of the isomerism in this. Chalo. So now when coordination number is 6, in that case we are going to study about 3-3 kind of arrangement. And in what manner 3-3 kinds of arrangement can be done, that we are going to study. So number B, when 3-3 ligands are there, and 3-3 ligands means what? M, A3 and B3. And in that case, what kind of isomerism is developing here, that we are going to talk about. So dear students, you can see A3 times B3 times, and total coordination number is 6. So metal ion is going to take 6 coordination bond in this portion. So you have to draw 6 coordination bond, and here also you have to draw 6 coordination bond in this pattern. Now you have to arrange 3A and 3B in the some tandemness, and then you will get the some isomerism, and that is very interesting isomerism. Okay, so here when we arranging this 3 one-sided, all are arranged at the one-sided. See here A, all 3A are one side, then remaining B are also having one side. So two kinds of ligands are opposing each other. They are facing each other. All the ligands are facing each other, and such different ligands are facing each other. That's why such kind of isomerism is known as facial isomerism, as they are facing each other. And this facial isomerism, in short, it is written as FAC. Okay, so this is our first kind of isomerism in coordination number 6, department B33. Okay, now here how could we arrange? So here arrangement is very simple. If you will change the position of A and B as usual we have done in previous case. So here B we will take, here A we will take. All other remain as it is. So now you will get the B in, they are making one starism. See, here they are making some starism. So such a point when we come to know, at that time we can say this B went to the meridional of this B. This A went to the meridional of this A, and that's why this kind of isomerism is known as meridional isomerism. Meridional. So such kind of isomerism is known as meridional isomerism, and in short we used to speak as a MER, meridional isomerism. So there are two kinds of isomerism here we are going to discuss. First one is facial, because all are facing each other, and another one is meridional, one element is went behind. So dear students, here we have the isomerism in the coordination compound, and we have complete first isomerism, that is the geometrical isomerism, which is developed due to the different geometry due to the coordination number. And with this we are ending the video here, and tomorrow we will meet with a new idea and new things. Have a good day.